Okay, so here's an example of how to determine whether a function is even, odd, or neither. So we have the original function here, and we need to compare that to the same function but with the negative input. So let's go through and replace all these x's with negative x. So we have negative x squared times cosine of negative x minus negative x times sine of negative x. And so you got to be careful with your algebra here a bit. Okay, now let's simplify this as much as possible. When you square this negative, it disappears and you just have x squared. Well, cosine is an even function, so this negative also disappears and just gives you cosine of x. And lots of ways to deal with this last one. Minus a negative x becomes plus a positive x. Sine of negative x is the same thing as negative sine of x. Now notice that this last part is not x minus sine of x, it's x times negative sine of x. So we need to go one step further now. We need to get rid of as many of these negatives as we can. When you multiply a positive x times a negative sine, that whole thing becomes a negative, x sine x. And so this is what we get, and we have to now compare that to the original. Now this equals the original function. And since f of negative x equals the original function, f of x is an even function. Okay? Here is another function. We'll proceed through the same process. We need to evaluate the function at negative x and see what happens. Now, if you're not comfortable with sine cubed of x, you could always write sine of negative x, since we're plugging negative x in, and that whole thing is cubed, and we'll see what happens with that. Negative x squared gives us x squared. Tangent of negative x, well, tangent is an odd function, so that gives us negative tan of x, plus sine of negative x, well, that's an odd function, so that gives us negative sine of x, and that's cubed. A positive times a negative here is a negative, so we have negative x squared tan of x. When we cube a negative, it's still negative, so this plus out here is going to become a minus, and we have sine of x cubed. Alright, and now we're going to go back to the shortcut notation for this since there's no negatives involved. Sine of x cubed is the same thing as sine cubed of x. And now if we compare this to the original function, they are not equal, right? However, this is the opposite of the original function. What do I mean by opposite? Well, it's the same thing as a negative 1 times the original. And so if you look at that, you have negative 1 times x squared tan of x plus sine cubed of x. The negative 1 distributes, and you get this. So the opposite of a function is multiplying it by negative 1, and since f of negative x equals the opposite of the original function, this is an odd function. Now, without going through an example, let's just say we ended up with, let's get rid of all of this. Let's just say instead of this here, we ended up with a plus here, okay? And when you compare this guy to the original function, they are not equal. That means it's not an odd function, or sorry, not an even function. And then if you look at this and compare it to here, it's not the opposite of this either, because the opposite wouldn't distribute the negative. And here the sine cubed is positive. So that means it's not odd. So if it's not even and it's not odd, that means it's neither even nor odd. So that's an example of what you might get for a function that's not even or odd.